In this video, we are going to be reviewing the different methods for factoring. Now, no matter what method we are using to factor, the very first step is always to factor out the GCF, the greatest common factor. So we always have to look at the terms and see if there is something that will divide all the terms to start with. Now, you will notice that this is one handout that will include all the different methods that we've been spending the past couple weeks on all in one handout. Now you will also notice that there is a link all on one handout that you can go to the link and do more examples, and these are the problems that we did in video notes in this class. So let's go ahead and take a look at our first example here, 18x squared minus 8. So there is two terms here. So when there are two terms, the first step is still, is there a GCF? So if we look here, both of these numbers are even, so we know that 2 can go into both of them. They both don't have x's, so it's just 2. So then 2 times 9 is 18, and then x squared, and then 2 times negative 4 makes negative 8. So that is always the first step, if it can be done. Then you ask yourself how many terms, and there are two terms here. So when there are two terms and the exponent is 2 and there's a minus, most likely it's a difference of 2 squares. So when there's two terms and a minus, one way or one thing you should try is to see if there's anything squared or anything times itself that makes the first term and the second term. So for example, 3x times 3x is 9x squared, and 2 times 2 is 4. So because we could find such numbers, then we can write it as 3x plus 2 and 3x minus 2. So one of them has to be positive, one of them has to be negative. It doesn't matter which one. And then whenever inside the parentheses the highest exponent is a 1, that means it cannot be factored any further here. So this would be our final answer here. Now, if you are determined to be successful and potentially catch any mistakes, when you're done, this takes like 2 seconds. You can grab your calculator, do it in your head. You take the GCF if there is one, and then you multiply it by the first number and the first number here. And check and make sure you get this first number here. Okay, now we're going to do it again and take the GCF and multiply it by the last two numbers, so the 2 and the negative 2. And make sure it gets you this number here. This doesn't mean your answer's right, but it's a good way to feel good about your answer if that works out. Now again, the whole point of factoring is if I were to multiply this out, so if I wanted to check that this is correct, if I distribute this, I would get 6x plus 4. And then if I bring down the 3x minus 2, and now I FOIL this, I multiply this out, I would get 6x times 3x, that's 18, x to the second. And then 6x times negative 2, that's negative 12x. And then 4 times 3x, that's 12x. And then 4 times negative 2, that's negative 8. And then we combine the like terms, and this makes 0, and we are left with 18x squared minus 8, and that is exactly what we started with here. That's how we check that we factored it correctly. Okay, so to recap, this is called a difference of squares. How do we know to do this? It's when you can find the same thing times the same thing that makes the first term and the second term, and there must be a minus. Subtraction in between. Okay. All right, let's do another one with two terms. So if we take a look at this example here, the very first step is to look for a GCF. So we look and see what can divide both 27 and 216. So the first thing we should do is take a look at the first number, or the smaller number, and think of numbers that can go into 27. So first of all, I know that I've taught you guys divisibility rules, and to know if 9 can go into a number, if I add the digits, so if I add 2 plus 7, that's 9, and if I add 2 plus 1, that's 3, plus 6, that's 9. So because 9 can go into the sum of both of these numbers, that's how I know that I could use 9. Now 9 is actually not the greatest, but a lot of times my students will choose 9 because they know 9 goes into 27, and then they do 216 divided by 9, and a lot of times people will use 9. So 9 is not the correct GCF, but I'm going to use 9 to show you what happens. So I'm going to use 9. 9 times 3 is 27. And then 9 times 24 is 216. Now, if you look inside the parenthesis here, 3 goes into both of these. That's how I know 9 is not the greatest common factor. So now I'm going to have to do it again and pull out 3. So 3 times x cubed is 3x cubed, and 3 times 8 is 24. But there was already this 9 here, so the GCF was 27, not 9. Okay, so if we go back to the original problem, if I try 216 divided by 27, it does go into it 8 times. So the GCF of this problem was 27. So the point is, if you don't pick the greatest common factor at the beginning, you have to keep looking to see if there's a number that goes into both of these, and keep going until you have that GCF there. Okay, so that was the first step, no matter what, is look for a GCF. The next thing we need to do is we look at how many terms there are. There are 2 terms here. So when there are 2 terms, we look to see if there's squares, if there's a minus, but because it's a plus, our only option when there's a plus is to see if there's anything cubed. So x times x times x makes x cubed, and 2 times 2 times 2 is 8. So remember, there's a key on our calculator. If you click the 3 button and then click second and the caret button right there, look, that is saying what times itself 3 times is 8. So that's how I know what to use if this number was much larger and I didn't know what times itself 3 times makes this number here. So I would use that button on my calculator. So then what I do is, if you're using the method I taught you, it's the SOAP method. I set up my parentheses like this and I write SOAP. And the purpose of that is it helps me remember the signs. So S means keep it the same, so I'm going to bring down that plus. O means what's the opposite of that, so a negative, and AP means always a plus sign, always positive. Then next what I do is I circle one of each and I drop it down here. Okay, then I take these 2 here and multiply them together, so x times x is x squared, so that goes here. And then 2 times 2, that's 4, and that will go here. Then what goes in the middle here is one of each. So an x times a 2 is 2x. And I call this the SOAP method. Now, if I'm committed to success and I want to catch mistakes, and this only takes like 2 seconds here, I take the GCF, the 27, and I multiply it to this one and to this one, and I should get what I started with, the 27. Then I take the GCF and I multiply it by the last number in the parenthesis, and I will check for the 216. So it's just kind of doesn't mean I'm right, It just means I feel good, I'm on the right track. So these are our two options. This is called the SOAP method. You use it, so how do I know to use this method versus this method? And it has to do with, is it a square or is it a cubed? So whatever's in the problem, if you can find 3 things to multiply to make each of these, then you know to use the SOAP method. If you only need 2 things to multiply together, you'll use, and there's a minus, you'll use a difference of squares. Okay, now let's move on to 3 terms. So let's go ahead and do 2 examples when there's 3 terms. So the first thing you do when there are 3 terms is you look for a GCF. That's always step 1. So there's nothing that goes into all of these. So then the next thing we do is we multiply A and C. Well, there's no number here other than 1. So we have to look for what multiplies to negative 18. So it has to multiply to AC. And then it has to add to B, which is negative 7. So we have to think of what multiplies to negative 18. So 1 times 18, 2 times 9, 3 times 6. Those are all the numbers that multiply to 18. Now I have to think about where the negative goes. So if it has to add to a negative here, this tells me the bigger number is the negative one in the pair. So 18 is bigger than 1, so it's the negative 1. 9 is bigger than 2, so it's the negative 1. 6 is bigger than 3, so it's the negative 1. And then it has to multiply to a negative, so then the other number has to be positive. So now I'm going to add these and find which one would make negative 7, and I would see that 2 and negative 9 work. So again, to recap, 2 times negative 9 makes negative 18, and then when I add them, it makes negative 7. So that's how I know where the negative goes and which pair of numbers to pick. Okay, then I'm going to take this and I'm going to put x here and x here, and then I'm going to put the 2 and the negative 9 in the spot, and then I'm done. That's all there is to it for this one. Now, if I want to make sure I feel good, I should be able to multiply 1 times 1 and get this number here, which is 1. And then 2 times negative 9 should give me the last number there. Okay, so this is called the AC method. So now let's do another one with the AC method, but you'll notice there's a number in the front. Okay, but we're going to do the same thing we did here, even though there's a number there. So the very first step is to see if there's a number that goes into all of these. Well, they're all even numbers, so we know that 2 can go into all of them. So 2. And they all have x's, so 2x is the GCF, so that's going to go in the front. So then 2 times 6 is 12, and if I have an x here, I need 2 more, because 2 plus 1 would make the 3. And then 2 times 5 is 10, and if I have an x, I need 1 more x, so these 2 would add together to make 2. And then 2 times negative 4 is negative 8, and then I would already have an x when I distribute here. So that is step 1, find the GCF. Then the next step, what we did here, was we made, I call it the rainbow. Make the rainbow here, and you multiply the 6 times the negative 4, which is negative 24. So I have to find what multiplies to negative 24, and it has to add to b, so the 5. So 1 times 24, 2 times 12, 3 times 8, 4 times 6. And then since it has to add to a positive, I know the bigger number matches the sign of this. So since this is positive, the bigger number is the positive one. And then because it has to multiply to a negative, one of them has to be negative. So that's how I know where to put the negative and the positive. Now I'm going to add these and see that negative 3 and 8 would work. So again, I'm picking these numbers because negative 3 times 8 makes negative 24, and negative 3 plus 8 makes 5. So that's how I know where the negative goes and which pair to pick. So now there's 2 different ways I showed you guys to continue. So I'm going to do it both ways. Okay. The way, this method here that I'm going to do is going to use the grouping method, which a lot of teachers that teach this class use the grouping method. And then the way that I do it, I personally think is a lot quicker. But again, you could do it the other way as well. So I'm going to show you both ways. So the way that I've been showing you guys is, again, the 2x doesn't go away. We got to drop it down here. And then you take whatever's here, just like I did here. There was just an x, and I put it here and here. I'm going to take the 6 and the x. I'm going to put it here, and I'm going to put it here, which that feels so wrong because this 6x times this 6x would be 36. If I FOIL this, I don't get 6. I put an extra factor of 6 in there, and we'll divide it out in a moment. So then I take this -3 and the 8, and I put it here. And then the very last step is to see if anything can divide both of these. So remember I put that extra 6 in. Well, now I'm dividing these both by 3 here, and I would get 2x minus 1 there. And then here I could divide both of these by 2, and I would get 3x plus 4. So remember I put that extra 6 in, but if you multiply 3 and 2, I'm essentially taking out that extra multiple of 6 that I had in there by doing that step there. And then again, if you're committed to success, you want to catch mistakes, you take this 2 right here, and then you multiply it by the first numbers in the parentheses. So this 2 and this 3. And check to make sure that you get this first number here, which was 12. Then you do it again, and then you check the last numbers in the parentheses and make sure it matches the last number here. That doesn't mean I'm right, but it makes me feel good that I'm on the right track. So now I'm going to do the same thing, same problem, but the other way to do it instead of this way is to get rid of this 5x and replace it with these two numbers here. So I could replace it with a -3x plus 8x. And then I'm going to bring down the -4 and bring down the 6x squared. And so the other way is to now convert the problem into, instead of 3 terms, now it has 4 terms here. And that's actually going to be what we have in the next box is what do you do with 4 terms? So when you convert this from 3 terms to 4 terms, you're going to do the same method from this box over here. So we'll take the notes here in a moment, but when you have 4 terms, this isn't going anywhere. This just gets brought down, so I'm going to ignore that. You're going to group 2 of them together and 2 of them together, and then take out the GCF. So what number goes into both of these is 3 and x. And then 3x times 2x is 6x squared, and then 3x times -1 makes -3x. Now I'm going to go over here, and 4 goes into both of these, +4. And then 4 times 2x is 8x, and then 4 times -1 is -4. Now when I move this hand out of the way, this should match this if I did it correctly, and it's factorable by grouping. So then both of these have the 2x minus 1 in common. And then I'm going to take the 3x and the 4 and I'm going to put them together in a parenthesis here because both of those terms are being multiplied by 2x minus 1 when I write it like this. And as you could see, we get the same answer as we did here. 2x, 2x minus 1, and 3x plus 4. This just converted 3 terms into 4 and used the grouping method. Alrighty, so now on to 4 terms. So when we have 4 terms, we're going to do exactly what we just got done doing in the previous problem. So first of all, is there something that divides all of these? No. So then we group 2 at a time. So I'm going to look here, ignore these 2. And think about what divides both of these. 9, and then the x squared is what they have in common. 9 times 2 is 18, and I have x squared, I need one more to make 3. And then 9 times 5 is 45. And then we already have enough x squareds to distribute here to make this term. And then over here, I'm going to bring down the minus. And then nothing goes into both of these, so I'm going to put a 1 when that happens. And then negative 1 times 2x makes negative 2x. And then a negative times a positive is a negative 5 here. So negative 1 times 5 is negative 5. Now, if I did this correctly, this should match this, which it does. So then both of these have a 2x plus 5 in common, so I'm going to bring that down here, factor that out, and then I'm going to put these two together. It doesn't matter if it's in the front or after, so I have a 9x squared minus 1. Then, before I circle my answer and say I'm done, this one's completely done here. The highest exponent's a 1, but this one, the highest exponent is not a 1, so we always have to look when there's two terms. These are our options here. There are two terms here. I have to look to see if there's a minus, must be subtraction. This one is for addition, if there's an add, or a subtract symbol in between. So when there's two terms and an add or subtract, so we have to figure out, could we do one of these on this problem here? Well, when I look at this, I know that 3x times 3x is 9x squared, and I know that 1 times 1 is 1. So that's how I know that I'm going to use a difference of squares. So the 2x plus 5 gets brought down, and then here I'm going to do 3x plus 1 and 3x minus 1. And then that would be my final answer. So if I want to check these and just feel good, I'm going to take all the first numbers, so the 2, the 3, and the 3, and make sure I get this 18 here, which I do. Then I'm going to take the 5, the 1, and the negative 1, and make sure I get this negative 5 here. So I'm always checking the first one and the last one by using that checking method. Again, it doesn't mean I'm right. It just means I feel good that at least that matches up there. Okay, so those are all our different methods for factoring. I'm going to add one more example here in the last box. So let's go ahead and do x to the 4th plus 5x squared minus 36. And again, the first step, no matter what, is to see if there's a GCF. So there's nothing that goes into all of these. So then there's 1, 2, 3. So when there's 3 terms here, we're going to use the rainbow, the AC method. So I'm going to go like this. And there's nothing here to multiply, so I have to find what multiplies to negative 36. And it has to add to 5. So numbers that multiply to 36 and adds to 5. So because it has to add to 5 and 5 is positive, the bigger number is positive. But it has to multiply to a negative, so I know one of them has to be negative. And then I'm going to add these, and I see that negative 4 and 9 would work. So again, negative 4 times 9 multiplies to a negative 36, and then when I add them, it adds to 5. So that's how I know to pick those. So then I'm going to put x here and x here, but the problem is x times x doesn't give you x to the 4th. So if I put a 2 here and a 2 here, then these would add to make 4. And then I'm going to put a negative 4 in and a 9 in. And then before I say, okay, I'm done, whenever the exponent is not 1, I have to check if it could go further. So there are 2 terms here. When there are 2 terms here, I have to look for a difference of squares or SOAP method. So when I look at this problem here, I know that x times x is x squared, and I know that 2 times 2 is 4. So this can be broken up to x plus 2, or factored further as x plus 2, and x minus 2. That's called a difference of two squares. Now this one right here has a plus sign. So when it has a plus sign, can't do this. So when it has a plus sign, I can look to see if I can use the SOAP method. So is there anything times itself 3 times that makes x squared? No. So I'm just going to bring it down, and this would be my final answer. Okay, so I would use this sheet as you're working and have this out, and the goal is come the test, you've learned this material, but I would keep this for future semesters because it has the video links in case you ever need a refresh on each of these types of factoring. You can go to this website here or type this URL in and get some more review.